a mass of 1.4 kilograms is attached to a horizontal spring. So let's say we have a mass equal to 1.4 kilograms attached to a horizontal spring with a spring constant, that's K, 75 Newton meters. The spring is stretched from equilibrium position by 5 centimeters. So the displacement is 5 centimeters, which we have to convert to meters by dividing by 100. It's then released. A, what's the maximum elastic potential energy? Elastic potential energy. So for A, we know that the total energy in a mass spring system is a combination of its kinetic energy plus its elastic potential energy. Its maximum elastic potential energy is when its kinetic energy is 0. So at that point, the maximum energy in the system, maximum EP, is going to be equal to the total energy. So we can literally do EPE equals 1/2 K x squared and plug in our values. 1/2 times x, which is 0.05. Whoops, let's back that up. One half times K, which is 75, times x, which is 0.05, and we have to square that. So EP max is 0.0938 joules. B. What is the maximum kinetic energy? So going back to our original equation again, total energy equals kinetic energy plus EPE. And when we have the maximum kinetic energy in the system, EPE is now 0. So we have E tot equal to this number up here, 0.0938, which also equals the kinetic energy maximum. See, what's the maximum speed? So the maximum speed is when there's no elastic potential energy and kinetic energy is at its max. So we have kinetic energy max equals 1/2 mv max squared, because its velocity is going to be maxed out at that point. So we have to get v by itself. The first thing that we do is multiply both sides by 2. This gives us 2ke on this side, and when we multiply by 2 on this side, the half cancels out, so we're left with mv squared. Now we have to divide by mass. Divide both sides by mass. Masses cancel out. We're left with v squared equals 2ke over m. We can take the square root of both sides, and we have the square root of 2ke over m. Our kinetic energy max, we said, was this guy over here, 0.0938, and we have to divide that by our mass, which is 1.4. And don't forget to take the square root when you're done with that math, and you should get a maximum velocity of 0.366 meters per second. And D, at what point will the maximum speed, at which point at what point will the maximum speed be reached? So the maximum speed is going to be reached when it's all kinetic energy, And when it's all kinetic energy, V max is going to be when the displacement equals 0, which is equilibrium.